in a matrix, okay, as I go through this, find the identity and inverse of a matrix, find the determinant of a square matrix, use a calculator to compute values with matrices, and apply matrices to model and solve real-world applications. We will probably get through to the scalar multiplying of matrices, and then we'll see what we're going to do. There's something we do with a transposition of a matrix or the transpose of a matrix that we might get to. Just depends on my druther, I guess, today. A matrix is a rectangular array of numbers. Matrices can be used to solve systems of equations and record data. Okay, you'll probably, if you're in a computer program, they refer to them as arrays. It almost to me like it's funner to deal with them that way because, you know, you have hooray, array, okay, as you go through. Okay, thank you, sir. Fumble. Now keep in mind, let M and N be the positive integers. An M by N matrix, read M by N matrix, is a rectangular array of M rows and N columns. So we go row columns of real numbers. We also use the shorthand of Aij for this matrix, and row column is always the order. So each element or entry of Aij, I rows, J columns, okay, of a matrix uses double subscript notation. The row subscript is I and the column subscript is J, all right? Now, the element Aij is a single position in the matrix. It's its address. So this is one element in the matrix. It's in row 1, column 1, okay? This one is actually in row 2, column 1, okay, as I talk about those subscripts as I discuss them, okay? Now, as we step through, we want to identify the element, okay? This is straight up from what we just did, IJ, row column. So identify the element specified for the following matrix. -1 is row 1, column 1, but I'm looking for row 1, column 3. Should be -1 as well as we step through that, okay? Please use this row column notation to identify the next 3 items that we've got going here. Now in B, we got row 3, column 2. So row 3, column 2, that should be a -4, okay? And C, I got row 4, column 3, can come out to be a 0. And then A is row 2, column 3. Row 2, column 3 should come out as -5 as we go through this, maybe. Row 2, column 3. Row 2, column 3 should come up as our -5. Any questions about that? Pretty straight up, matrix basics. Now, to find the order, people freak out. What's the order? I mean, do I have to like do them alphabetically? No, the order of a matrix is M by N. This 2 by 3. You don't multiply them together. The order is 2 by 3. Okay. If M and N are equal, we call it a square matrix because, you know, it's the same measure. You know, if it's 4 by 4, 8 by 8, 2 by 2. So find the order, and the order is row column order. Everything's row column when we're doing it, so keep that as your basics. You got row column for your order. So, and B, you got row 4, column 2. So it's 4 by 2 is your order. And C, the matrix is a square, 3 by 3 square. Now, to stay with the idea that matrices can be used for like just crunching numbers, matrix addition is subtraction. We can add or subtract matrices of the same order. And remember, has to be the same order. There's a one-to-one correspondence with this add subtract thing because I've got to have the same row column correspondence. Otherwise, I've got an issue. Okay. And we talk about it here. Definition of matrix addition is matrix subtraction. If I'm going to add matrix A, this capital A represents our matrix A, and matrix B is the M by N matrix, or M rows, N column matrix, then I can add the corresponding members of each row column combo to each other separately. Okay, so basically if I can slide the matrix on top of the other matrix, and there's, you know, like the 3 goes to the 0, the 6 goes to the -1, the -1 goes to the 6, -3 goes to 0, -5 goes to 2, -1 goes to 3, no problem. That's what I'm doing. So when I'm doing this, I'm going to just talk about 3 plus 0, 6 plus -1 is 5, -1 plus 6 is 5, -3 plus 0 is -3, -5 plus 2, -3, -1 plus 3 is 2. That's it. Corresponding spots in the matrix here. I just had you do 6 quick questions, adding really fast. Okay. Well, I could do the same thing with subtracting. Okay. Go, it's your turn. Subtract. Remember, order matters. So the first one's gonna be subtracted from the second. Okay, go ahead, do B, and then think about C for a second. Over here. Yeah, just getting that one done. Now, keep in mind, it's kind of thinking about a one-to-one correspondence because you have to have a row column for adding and subtracting. Row and column have to line up. So a -5 minus 6. Well, that should be a -11. Okay, 2 minus -5. And that's a plus, so that's going to give us a 7. -2 minus -6 is going to just give us a +4. Then I go to the second row, okay, and first column, 4 minus 1, 3, -2 minus 1, -5, minus 3, excuse me, and 0 minus my -3, which is going to give me a +3. Questions about it? Pretty easy, right? Remember, in able to do this, I have to have row column order as I step through. Shoo. There you are. Clem. Okay, so as we're going through this, keep in mind it's that one-to-one thing. They got to have the same order. Okay, they got to be the same size, row column wise. Okay. When I come to this, people will try to do all sorts of funky stuff with this when I'm adding or subtracting matrices. But you got to keep in mind there isn't it's not in the same position, and I don't want to twist this. So we cannot add orders are different. They can't be added or subtracted because the orders are different. The orders have to be the same in order for us to add or subtract the matrices. The orders have to be the same in order for us to add and subtract the matrices. Okay. Now, you want to do some number crunching. Okay. I want you to do this with a partner or a third person in your group. I want you to read the problem and answer the question. Read the problem, answer the question. You might benefit from splitting up the work, 2 different people. Now keep in mind, after you enter this in your calculator, we just went through matrix entries into a calculator, you just hit matrix A plus matrix B and you use that second value to get over. You hit enter and this is your result that comes out, okay? It just comes out in a matrice, but those stay in your calculator until you change them. They store them until you cancel or you clear out your memory or whatever, okay? They'll be there until you adjust them. All right, so keep that in mind. If you go back in and you have a matrix mismatch, okay? If there's some sort of issue, you're probably adding a matrix that's bigger to one that's smaller and it won't work, right? So let's slide on to our next problem here. We're talking about scalars. And scalars are real numbers, the product of real number k in the m by n matrix A. All you're going to do is multiply that value by every entry inside your matrix. That's it. So if I've got an m by n matrix, I have m times n multiplications to do. That's it. So in this case, I got 5 times 4 and 3. Well, that's 12 and 15 when I'm done. If I can get rid of my marker. Or 12 and 15, 20 and 15. I don't know where I came up with 12. I was looking at 4 and 3. Are you all right with that? That's it. But I got to remember I multiply all of them. Okay? So negative 5 times negative 3, negative 5 times 0, negative 5 times 0, negative 5 times 5. Done. You can set this up in your calculator if you're doing a really big matrix, or if you're multiplying by something like we're going to set up in example 3. And I'm going to have you use your calculator to work with your matrix so you can get help on it if you need to. Okay? Do the last one. Remember, a scalar times a matrix. You just take the scalar and every member inside the matrix gets multiplied by it. That's all you're doing. So I got 25. 5 times 5 is 25. 5 times 1 is 5. 5 times 1 is 5. 5 times negative 2 is negative 10. Okay? And 5 times 1 is 5, and 5 times 2 is 10. That's all I'm doing. Next. Using a scalar multiplication, the Consumer Advocacy Group has computed the mean retail prices for brand name products and generic products at 3 different stores in a major city. Prices are shown in the 3x2 matrix for store A, store B, store C. They're generic and the regular brand names. Now, the city has combined sales tax of 7.25%. Construct a matrix showing the comparative prices with sales tax included. Now, when we conclude sales tax, you got to keep in mind, we're going to have the regular cost plus whatever the sales price is times whatever its cost was, okay? But in matrix multiplication, we just talked about scalars. This is the same as 1.0725x, right? That's all I'm going to do. That's my scalar. So when I set this up, I rewrite the matrix, and I've got my scalar all set. So what I want you to do is enter this value into your calculator and enter the matrix, the 6-member matrix into your calculator, and use matrix C, and now use it as a scalar and see if you can work it with a scalar and how you do it. Now, after you put this into your matrix, we're really talking about the idea in your calculator. You're going to go 1.0725 times matrix C, and you hit enter. It should work out that you get your final answer of 4.26, 4.05, 4.02 in your net column, and 3.90, 3.96, and 3.94. They should come out, okay? The beauty of this is that you can check over your matrix that you've entered in your scalar quite quickly a couple times, and then just hit enter. And then the only real issue with these answers, when you have your calculator with you, is you transposing numbers because you're just writing too fast. Okay, so let's slow it down a little bit. Are there any questions up through example 3? You okay with the editing of matrices, being a little cursor through that back and forth? Okay, all right. Now, the zero matrix. I'll give you time to get these down and I'll talk about it. Okay, so here it is. The zero matrix is a m by n, row by column, matrix 0 or matrix O, which is, it's just equal to 0, consisting entirely of zeros. Okay, whatever it is. If it's a 2 by 2, it's got zeros across every row and every column down. Okay, so the O is the additive identity, excuse me, for the set of all m by n matrices. So A plus O is just A. Okay, the m by n matrix B, consisting of the additive inverse of the entries of A, is the additive inverse of A, so A plus B equals 0. So, I mean, I'm just multiplying matrix A by -1 to get to matrix B. Okay, so we're talking about additive inverses, additive identity, and we have a identity matrix that has ones in it as we go through, and we'll talk about that when we get there. Now, to find the product of AB of two matrices, finding products, it's a little different. It's not a one-to-one like it is with the row column, and they don't have to have the same order. So in general, we're going to be doing this. A m by n row by column, okay, multiplies an n by p matrix, okay, and then I end up having an m by p resulting matrix. The columns and rows must be the same, and order matters. If I multiply A times B, I'll get a different answer if I multiply B times A. Okay, but we'll talk about that in a little bit too. But let's talk about this ending matrix size. Okay, as I'm going through here. So here's how we do it in a nutshell. If I go A, B, A times B, E times G. So A times E, B times G, and I add their products together. Okay, it is the pattern that we do this, and this is what your calculator will do. But please keep in mind, you will have a no calculator part of this test, and you will be asked to multiply a 2 by 2 times a 2 by 2. Okay, or a 3 by 3 by a 3 by 3. You should be able to do both, but it's row column. So top row, first column gives me the first corner. Top row, second column gives me the other corner. So I got A times F, let's get this color coded, A times F, B times H. A times F, B times H gives me those two as I go through. So I add them together. I take the product and I add the results. So there's some. Next, CD times AEG. C times E, D times G. Order matters as I go through. Okay. My last one, I haven't used black, so I'm going to go to the next column, F and H. I haven't used black, and I go ahead and grab it. Let me get that right. And that's the one I'm doing. Okay. We are going to practice this to make sure we get it. Okay. So find the product of AB if possible. First, number of columns in this matrix, number of columns has to equal the number of rows. Okay, order matters. In this particular case, when I go A times B, I've got 2 times 1, which is 2, 1 times 0, which is 0, -3 times 1, which is -3. I add them together and I get myself a -1. Okay, for my results. Remember, I'm just going to try to do it this way. My second one, 2 times 4 is -8. 1 times 2, -3 times 0. Okay, my other matrix there. And I'm just going to show you what I'm going to add together. I got -6, my other entry. Okay, now keep in mind, I've already taken care of these. I'm going to go to this second matrix or the second row, I should say. Oh, good Lord, the things I'm doing. I'm going to take this one and multiply it by these two to get my next two entries here and here. Because I'm going to go from a 2 by 3, 3 by 2 to come up with a 2 by 2. Remember, 2 by 3, 3 by 2. Those are the same. It's a 2 by 2 for my answer. Okay? So my last one, 0 times 1, 0. 1 times 0 plus 0. 2 times 1 is 2. That's 2. 0 times negative 4 is 0. 1 times 2 is 2. And 2 times 0 is 0. And I get 2. So this is my answer matrix of A times B. Okay? Keep in mind that the columns of the first matrix and the rows of the second need to line up. Okay? Do I have in this second one, do the rows, the columns on this one line up with the rows on this one? Okay? I can go B times A because it's a 2 and 2. Okay? But I can't go A times B. In this case, this is undefined. Cannot multiply A times B. I can multiply B times A, okay? Because it'll be defined that way. Questions about that so far? Okay, now you can use your calculator on this, okay? But I want to caution you. On the test, there are going to be two parts. This is a no calculator part example. These three are no calculator questions. You may check your work with your calculator, okay? Because I want you to practice that, because when we get to the larger matrices, you got to be really good at moving around in your calculator environment. So C, D, and E, I want you to take the next 6 minutes. Do the multiplications, check them with your calculator, see what's up, okay? Go ahead. Okay, now that you've had time to do the matrices yourself, should be checking out. Remember, it's 3 times negative 1, 3 times negative 1, negative 1 times 5. You're going to add those together and get a negative 8. And you repetitively do that the whole time. And suddenly I have all the answers here. And you should be able to follow along with yours. If there's any concerns, let me know. But the biggest thing that you need to be aware of as you go through this is a 3 by 2 matrix, and it's times a 2 by 2 matrix. This value, these two values, must be the same, and your result is a 3 by 2 matrix, which is this. This is a 3 by 2 matrix. Okay. In D, I got a 4 by 2 matrix. And I've got a 2 by 3 matrix. My final answer should be a 4 by 3 matrix. And then the last one, I've got a 2 by 3 as I'm going through, and a 2 by 3 here, and these aren't the same, and that's why the product is undefined. Okay, I hope things are going well. Go ahead and get the assignments done, and we'll continue on with examples 5 through 9 on day 2.